Hello and welcome back to Universe Sandbox 2. So, happy Thanksgiving. I'm kind of late by 2 days, but to those of you who celebrate it, happy Thanksgiving. I hope you all had great turkeys, and for those of you who have ham, and then all the other foods that come with it. But today we are going to be testing a slightly less happy thing than Thanksgiving. We're going to be testing what would happen if a sufficiently sized gas giant smashed into Jupiter. Because Jupiter does a few things that are very important. Actually, Jupiter is big enough that it has an effect on the gravitational pull on the sun, and it causes the sun to go in tiny little circles. But if we raise its mass through a collision, or accidentally destroy it through a collision, what's going to happen, and will the debris let out from this cause serious issues throughout our solar system? So we're going to start off by just grabbing a random gas giant, and we're going to let a few, we'll start with one. Boop. Oh, okay, so that is going to orbit, because Universe Sandbox 2 has no clue what I'm trying to do. So what we're going to do is we're going to actually hit Jupiter from this side, because I just realized that this is going to be better for us anyways, because it'll slow down Jupiter, and you guys will see what that does. It'll do interesting things. So let's grab a random gas giant, and the first one is going to hit Jupiter at a fairly decent speed, because Jupiter is not moving slow. And Urquhart is going to smash into Jupiter's surface. Now, the first instant this happens, we're going to see a lot of things happen on Jupiter. The first thing is its temperature is rising rapidly as all of the gas ignites, because when you have something mostly made out of hydrogen and other flammable gases, and then you heat them up to thousands of degrees and possibly introduce oxygen into the mix, it becomes a very explosive situation. We can also see ripples in Jupiter as its bands are messed up because of the immense amount of impact force here. So, I think that's going to be most of the heating up for Jupiter. It's probably going to hit about 5,000, 6,000 degrees by the end of this. But we can also see under its motion that Jupiter is changing speed. I don't know. It should technically have lost speed. We're going to see a lot of debris come out of this. Jupiter's going to eat it all up, though. So Jupiter came out of this losing little mass. It lost some mass, but not a ridiculous amount. And Jupiter is hot enough that it's now glowing red. For those of you who have no clue what that would look like from Earth, let's do it, because I'm one of those people. I'm going to admit I have no clue what this is going to look like from Earth's surface, but there's Jupiter. Wow, that's actually really easy to see. Let's go down to near Australia and look into the sky. Where's Jupiter? Can we find it? If we can find it, that would be awesome. It's gonna be a bright... Oh, there it is. That is Jupiter. So it is actually now the most visible thing in the night sky almost. It is very, very red, very bright, and we can pick that out of the night sky. I mean, the North Star may be a contender for it, but that is pretty clear. So now that we know that people on Earth would be able to see such an event, the world scientists would be scrambling to figure out what the heck just happened, because the biggest planet in the solar system doesn't just go red all of a sudden. But let's speed things back up. Oh, is the game is paused, isn't it? Okay, so let's slow things down. Okay, so Jupiter is going to stop being red. That's just a part of cooling down, because space is very cold. However, it doesn't instantly freeze because there isn't much matter in space to transfer the heat to. So space is a vacuum, but it isn't a perfect vacuum. There is some stuff in space, some particles, and that is what it's transferring its heat to. But it looks like we're going to have to hit Jupiter with another gas giant to really have an effect. So Jupiter currently has a speed of 13.3 kilometers per second. What we're trying to do is we're trying to get an impact that's going to kill that. Because it's the way that we can actually make a response that'll make this video interesting. So Jupiter is going to get slightly sped up by the attraction of this object, which is named Lust. Yes, Lust has always been a planet. And now Jupiter is gaining a lot of speed, but when it hits, Jupiter is going to lose that speed because of the impact force, and we're hoping that it'll lose a bit more speed than it gained. So we're about to collide, and let's see if this throws off Jupiter's orbit at all. Here it goes. It's dropping, it's dropping, it's dropping. Look at its orbit. It got slightly smaller. So now I know what I need to do, because I have a plan for this to make this interesting. We are going to do that right there, and we are going to use an impact to freeze Jupiter in place. We're just going to kill off all of its velocity with an impact. Now, this would have some serious ramifications if it happened, which is why we're doing it, because it would be awesome. Well, not for us. It would seriously mess up our day as humans. Slight issues with it. Here we go. So we're going to hit Jupiter the opposite of its velocity, and we're going to match. Actually, we're gonna go twice its velocity in this direction to try to. Let's go 3 times its velocity. 30 kilometers per second is going to be enough to wipe that grin off of Jupiter's face. That non-existent grin, because Jupiter is a planet. Okay, here we go. So Innispore, how much mass does this have? This does not have enough mass to do any real effect on this. We're going to raise its mass. First, we're going to make it mostly hydrogen, because that makes it more like Jupiter. And then we're going to increase its mass to, what's Jupiter's mass? We're gonna do 100 Earths. This is going to, now it's too big. We need to shrink it down. To shrink it down, we're going to increase the amount of silicate, denser materials, and that's good. That's going to work. Let's see what happens. This is going to seriously mess with Jupiter, unlike the other 2 times. This is going to have a real effect. Looks like we may actually miss. So let's make sure we don't miss by fixing. Okay, here we go. We're not gonna miss now. Let's keep an eye on Jupiter and its motion. Ooh, it's gonna be smacked right in the face. Sorry, Jupiter, this is going to be painful. Ooh, and it's actually been sent in the other direction. Whoops. That was not the intended outcome of this. This is actually going to send Jupiter out of the solar system at this rate. We're going to change that. That's not what happened. We're going to pretend the object that hit Jupiter was slightly smaller and going with a little bit less speed, and it managed to make Jupiter's speed negligible. Let's say it was going 3 kilometers per second after the collision. And this is how it's going to actually affect us, because going 3 kilometers per second, Jupiter is going to come our way, because there's nothing much holding it in orbit. It's going to come towards the sun, which means it's going to swing by Earth on the way. That's not really the important part. If we're lucky enough that it happens to interfere with Earth, that would be interesting, but that's probably not what's going to happen. But it's going to smash into the sun. Or it's not going to smash into the sun. It's going to be ripped apart by the sun and really mess with the sun. So here we are, and wow, we're actually going to get really close to Earth. Actually, no, we aren't. That was kind of misleading. We're gonna get close to Mercury, though. Hey, Mercury, how are you doing? And here's the sun. So, if it was sent to a very small speed, it would come near the sun, and probably the Roche limit would kick in and rip Jupiter apart a bit. But let's see what would happen if it completely stopped Jupiter. Now, if Jupiter had stopped moving, it wouldn't have to stop moving, it would just have to get really close to, which means something with a similar speed and mass of Jupiter hit it at the exact opposite direction. Very unlikely to happen, but what's going to happen is Jupiter is going to smack into the sun. Now, Jupiter lost a lot of mass, so it may not do too much to the sun, but Jupiter hitting the sun is definitely going to have ramifications for the entire solar system. Mainly, the sun's magnetic fields are going to be triggered, and it's going to shoot out a whole lot of solar flares and other such events are going to occur across the sun. It's going to be extremely bright. If we look from Earth, let's see. Now, the sun just got its entire chemistry off-balanced, and now it's glowing more of a blue than an orange, which means everything is now tinted blue on Earth. I'm fine with this. I like the color blue. Look at that. The collision is so bright, it's like brighter than the sun used to be. You would not want to look at this without wearing something special, because this will really mess up your eyes. And here we see the sun expanding. Now, Jupiter hit the sun in a way that the sun now is not able to as efficiently perform nuclear fusion, which is causing it to expand as it loses heat, which means it can't collapse on itself as well. It's causing a whole lot of problems. The sun expanding is actually a very, very bad thing for us people on Earth, because we're going to see the effects of this rather quickly. Let's jump to Earth and check the temperature. How is Earth being affected by this? Is it going to survive? Obviously, the sun being affected is going to mess with our temperature quite a bit, but the question is how much? The Earth is cooling down, and it's not happening slowly. This is over the course of a few months. It's now dropped a few degrees Celsius in total. Can we get a look at the surface? Yes, we can. Actually, all we have to do is open this up, and I remember there was a way to do this, or did they remove it? I can't expand this view. Oh, come on. I remember I used to be able to expand this. Oh, that's horrible. Oh, darn it. There used to be a really convenient way to open this up. Well, we're gonna have to look on the globe. So as you can see, looking at America especially, the ice age has begun. The average global temperature is dropping way, 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 way further than we'd ever want it to. Now, in these months, we could actually attempt to counteract this by polluting. Now, questionable how much we could do, but let's see what we can actually try and emit some carbon dioxide to save the world. 8 degrees Celsius. Let's see, if we were to really try and like double the carbon dioxide in the atmosphere, let's see if it would offset. It seems that it slowed it down for a second, but no, this is going to cause real issues. Let's look at a graph of the Earth's temperature, which is dropping, and let's see what happens when we add some carbon dioxide to the mix. Actually, we're counteracting it. All we have to do is pump more carbon dioxide than is really humanly possible into the atmosphere. But what this is going to do is it's going to cause a runaway effect that's going to get much worse in the long run, because we have no way to undo it. Although it seems to be balancing itself out. I think we would have to be consistently pumping ridiculous amounts of carbon dioxide into the atmosphere to actually make it do a good job. So yeah, we're actually steadying out at about 10 degrees going, you know what? That actually may have been a feasible solution. The amount of carbon dioxide we put into the atmosphere, though, is it would be extremely challenging to do. We'd have to burn off pretty much all the oil and stuff we have on the surface, and it would actually probably that many parts per million. It may actually affect our breathing at that point. I'm not going to say that for sure, but that's a lot of carbon dioxide. And what actually triggers you wanting to breathe out is carbon dioxide in your lungs, not the lack of oxygen. So that may have some pretty serious health ramifications, along with whatever pollutants were released along with that carbon dioxide. It would be bad. So now that we have gotten rid of what we just did, and we are now actually letting the Earth freeze, let's salute the Earth. Bye, Earth. It was nice knowing you. You were a good planet while you lasted. As the global surface temperature drops, there is not much left that isn't coated in ice. At 7 degrees Celsius, of course. For Fahrenheit users, there isn't Fahrenheit in this game, so you guys, technically I'm a Fahrenheit user, so. But I know the Celsius scale just because of my computer when you're watching those temps. Okay, at 3 degrees Celsius, things are really, really bad. All of Europe is frozen. Mexico is even frozen. Everything is frozen. Nothing is growing. Everyone is starving. All the cities, all the electricity, everyone's rioting because they're starving to death. You know, they've had to go through this for months with it slowly getting worse. The blue sun in the sky is not providing enough heat, and any second now we are going to be freezing at the temperature at which water freezes. Now the effect is slowing down because it's starting to balance out, but it's going to hit freezing temperatures before then, and now we are in the negatives, which means the ocean is going to start to freeze. Even with all the salt it has in it, the ocean cannot handle the temperatures for much longer. So, speeding things up a little bit, ice is going to start forming in the ocean, and it's going to start floating to the top because ice floats. This is going to cause more heat to be reflected, and now we have a runaway system. As you can see, we're getting colder and colder and colder, and the oceans are beginning to freeze at the poles. So there is a bit of blue left. Antarctica is having a healthy recovery from global warming. The planet looks absolutely wonderful for Christmas. Just in time for Christmas. And now it's starting to somewhat balance out, but this is not going to stop. It's going to just slowly and slowly get worse forever. I like how you can still see city lights through the snow. And there goes all of the water. It's all gone. It's over. Pack it up, guys. Earth is now frozen. And Earth isn't the only thing that's been messed with. Let's look at Venus. How is Venus holding up? Because Venus is notoriously burning hot. Venus is fine. Mercury, though, is actually quite cool now. It is actually on its lower level getting to not a livable temperature, but not absolutely, it's still absolutely horrible, but not as absolutely horrible. Mars has got to be really cold. Yes, Mars is not doing so well either. The best hope for humanity is to somehow terraform Venus. Do we have enough time for that? No. No, we do not. You know what? Let's do it. I know people don't like the whole half-hour videos. Well, some people do, some people don't. But let's quickly terraform Venus. Give Earth, the people of Earth, a new place to go. Their Captain Elon Musk will bring them to Venus, and everything's going to be okay. Why not Mars? Well, Mars is kind of doomed. Mars is even colder than Earth, so not the place we want to go. Now, if we find a way to lower the albedo of Venus, we could start letting the heat out, although more sunlight would hit the surface. So this is kind of a balancing act. I'm not sure if we can let enough heat out doing this. No. We're going to have to then increase the albedo to probably 99%. Yeah, so that means 99% of the sun's energy is being reflected from Venus, which means that temperatures are actually dropping, but they're still at 80 degrees. So we're going to do 99.5%. It's going to say 1, but it isn't 1. Okay, so we're going to do 0.997%. Oh, that is actually making it cold. So we'll do 996. 0.996. 99.6% of all heat is being reflected. And it's a cozy temperature. I'm not going to lie. Most people aren't going to like it. But it ranges from livable to very, very warm. And that is a better outcome than on Earth right now. And if we add water and such, we could probably make Venus somewhat livable. Let's make it so that we can see. First off, that's important, being able to see the surface. That's going to be under temperature, I think. Where is it? Where is the view atmosphere? Where is it? I don't want to see the atmosphere. It's too hard to see. Oh, it's 94.3% like Earth. Wow. Good job, us. But that doesn't answer the question. How do we see? Ah, there it is. Okay. So, okay, I added a little bit too much water. A little bit too much water. What we'll do is just decrease that a slight amount. Oh, look! That doesn't look too bad. I can live there. You know, I will get a space shuttle ticket right away. RIP space shuttles. We don't really use those anymore. And we'll all travel to Venus, and we will live on Venus. It'll be great. And you know what? Because of the extremely toxic atmosphere, we're going to have to deal with that a little bit, realistically, too. But the amount of carbon dioxide in the atmosphere of Venus means that plants will grow really well, so no more starving. And the soil's probably really rich, too. So, congratulations. We now live on Venus. See you all next time. Bye.